Good day, everyone. So for this presentation, we will be talking about how we are going now to convert different number systems to another number system like base 2 to base 8, base 2 to base 16, or base 2 to base 10, and vice versa. So we call this now the base number system. So the best way for us now to get some perspective on the concept class of a base number systems is to, of course, we have to review on how our decimal system or our base 10 positional system works. Okay, so just for have an idea class, so say for example, if you have 453, we can rewrite the 453 class as 4 times 100 plus 5 times 10 plus 3 times 1. Then, of course, we can rewrite again this 110 and 1 as exponential expansion. So 100 is 10 raised to 2, 10 is 10 raised to 1, and 1 will be 10 raised to 0. Thus, the name class base 10. So our number system is base 10. So we need this concept class so that when you're going to convert base 2, base 8, or base 16 into base 10 positions, then we use this concept class. Okay, so you have to be of course, go back a little bit now or recall your concept class of how our number system, okay, is being introduced to us in a positional system. Now, when the base 2, okay, the expansion is what we call binary expansion, okay, and your b is equals to 2, indicating that it is base 2. Then each coefficient for base 2 is only the digits 0 and 1. So for base 2 class, we only have 0 and 1s combinations. And these two digits are what we call binary digits. Thus the name bits. Okay, so taken from the BI and the TS. So sometimes you will encounter the word bits. So this is referring to the binary digits or base 2. While our number system class is base 10, which is what we call decimal system from the Latin term decem, meaning 10. So other common bases besides base 2 and base 10, we also have the base 8, we call this the octal, and the base 16, which is around the hexadecimal system. So we only focus class on these four: base 2, base 10, base 8, and base 16. Of course, there will be base 4, base 5, base 7 that we can think of, but these are the common: base 2, base 8, and base 16. Okay, so for us now to familiarize with the symbols that we use for the different bases class. So like in base 2, we only use the numerals 0 and 1. So we don't see any 2, 3, 4, 5 in base 2. For the octal class, our digits are only from 0 to 7. We cannot see 8 or 9 in base 8. While base 16, it's from 0 to 9, its combinations. Then we also have the letters from A to F. And of course, our numeral system from base 10, we have from 0 to 9 and its combination. So this is where we are familiar with. Now, when the base is greater than 10, like in the hexadecimal, we use the letters A to F, but we represent this by the digits 10, 11, 12, 13, 14, and 15 when we convert class. But once we are done converting them, then we go back again to its corresponding letters. Okay, so to avoid any possible confusions later on, so actually it's easy to find class the decimal value of an integer from its base b representations. Okay, so how are we going now to convert, okay, base 2 to base 10, base 8 to base 10, or base 16 to base 10? Now, starting off with a binary digit, so remember class that in base 2 we only have ones and zeros. So how are we going to convert this into base 10? Okay, so this one is we need its binary expansion. You might be wondering, sir, paano nyo nakuha yan, sir? How did we have this 2? Remember that this is base 2, so we will have our bases as 2. Now, to find out class what will be the maximum exponent, you have to count the digits. So here we have 5 digits. So 5 minus 1 is 4. So therefore, we have our highest exponent as 4. Now you are going to spread out now 11001 here. Then you multiply this by 2 to the power of 4 as the highest because we have 5 digits minus 1. So that is 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1, and 2 raised to 0. And these are the digits 11001. Okay. So once we have now this expansion as what we call it, then only consider those base 2 numbers with 1 multiplied to it and remove the zeros, because of course class this will give us 0 as a result. So for simplicity's sake lang, then we just need only those digits that has only 1 being multiplied to it. So only the red ones will be considered. Then we are going to expand what is 2 raised to 4, what is 2 raised to 3, what is 2 raised to 0. So by doing that, we have now 16, 8, and 1. So any number class multiplied to 1 is the number itself. So therefore, if we're going now to add all of these digits, so 16 plus 8 plus 1 is equals to 25. So therefore, the binary digits 11001 base 2 when converted to base 10 is the same as 25. You can remove the word base 10 class without using or putting now the base 10, just simply 25. It means that we are using base 10 because it's our number, our numeral system class. Base 10 kasi tayo. Ayan. So I still put here the base 10 just to clarify lang, parang you notice that this is base 10. Okay, so that's how we convert class base 2 to base 10 system. Okay, so another example class is this one. 101011. Convert this to base 10. So again, always count the number of digits. Okay, so 101011, there are 6 digits. So 6 minus 1 is 5. Thus, we have the largest exponent as 5. The base are all 2. Okay, so notice that. Then, we spread out these digits, 1, 0, 1, 0, 1, 1. Then, consider only class those digits that are being multiplied with 1 for easier computations, because any number multiplied to 0 is 0. Then, only the red ones will be considered here. Then what we do now is we are going to expand. What is 2 raised to 5, 2 raised to 3, 2 raised to 1, and 2 raised to 0. So by doing that, of course, we are going now to expand them. So 2 raised to 5 is 32, 2 raised to 3 is 8, 2 raised to 1 is 2, and 2 raised to 0 is 1. So any number class multiplied to 1 is the number itself. Then all you have to do class is we are going to add them. So 32 plus 8 plus 2 plus 1 is equals to 43. So therefore, 101011 base 2 is the same as 43 base 10. Okay, so it is easy class because all you have to do is that first how many digits are there, then that will now determine what will be the maximum number of exponents. So we have 6 digits, so 6 minus 1 is 5. So our maximum exponent or the highest exponent will be 2 raised to 5. We can apply this also. Okay, we have here another example class. So we have 2, 4, 6, 7. Okay, so in this case, notice class that there are 7 digits here. 1011001 base 2. So there are 7 digits. So 7 minus 1 is 6. So you notice here that the highest exponent of the binary expansion is 6. Then multiply now these digits 10110001 by your binary digits. Okay, starting off with 2 raised to 6, 2 raised to 5, 2 raised to 4 until 2 raised to 0. Yan. Then, only consider class those base 2 numbers that has 1 as a multiplier. You just remove those zeros. So, concentrate only on the red ones here because those are the only numbers that will give us non-zero results. Okay, so we expand 2 raised to 6, 2 raised to 4, 2 raised to 3, 2 raised to 0. We expand that. So 2 raised to 6 is 64, 2 raised to 4 is 16, 2 raised to 3 is 8, and 2 raised to 0 is 1. So all you have to do, class, is you add because any number multiplied to 1 is that number. So adding 64 plus 16 plus 8 and 1 is equals to 89. So therefore, 1011001 base 2 when converted into base 10 is equals to 89. Okay, so I hope class you have now an idea on how to convert base 2 or a binary digits into base 10. Okay, so see you again class for our next presentation. Bye-bye.